So is it mute? Is it on? Right, it's on, right? So probably our this is the class that up to this apply. There will be the exam range, okay, and then we will be able to cover some contract theory today, which is not included in exam, but I think it's important for application in our business. So we will do contract theory. If you have time, I upload some other topics. I mean, if we figure out some time, because we will do the exam at the very last hour of the next class. Okay, just 1 hour. So do note that the exam will have probably more questions that you can do it in 1 hour, because I just want to see how well you're doing. So don't expect you finish everything. So that is perfectly normal if you are unable to get everything done. Okay. So I guess let us put signaling game to solve them in a more realistic cases, right? Because I think we discussed last time how to solve this type of game where it's easy to check because choice of the sender is only left or right, and only two types of sender, and the receiver only have choice of up or down, right? So that makes analysis pretty easy. So you can basically list out everything, and then you can solve the game completely. And if you go to allowing the sender choice is continuum, and the receiver also allow continuum, then the model will be much more complicated, right? Because the search space is pretty complex. So that's what we do. We will look at the famous span signaling game. Just recall if you forget, but it's allowing more than one firm and only single worker. But the fact that later you see when firm engage in Bertrand competition and competing for the worker, that means that it reduced the problem of two firms to single firm, because firm are symmetric, and the choice of the firm is also much easier because of Bertrand competition. So they're paying the wage as their expected productivity. Okay, but let's see the model again, and then to make sure that you understand what's going on there. So there's still there are two type of worker, okay, and high or low, high is Q, and now we allow the worker to send message. It's no longer high or low, but a continuum. So you can see the education is from 0 to infinity, and the cost is represented by the type dependent, right? If it's not dependent, the signal is useless. Okay, and in that case, you should go to the model we call chip top model, or then in that case that would be more appropriate. And when the signal is costly, that means that, right, the education is costly and is increasingly so. And the most important part is this single crossing. It's saying the marginal cost of getting education for the high type is lower than the low type. Okay, this is important because otherwise signaling cannot distinguish, right? Because you would expect the more costly for the high type, so low type to get education. And here we have symmetric firm, and they only observe education and make offer to the worker. Okay, so that's and we assume education is useful. Okay. Of course, this is not necessary. You can see if this is flat, it's also work it out. And we allow the productivity to be higher, marginal productivity higher for the higher type, right? So more capable worker, the marginal productivity is higher, okay, for the same education level. And here we tell you the worker, when he look at the offer from the firm, he only interested in the money. So he go for the offer that gives her or him highest value. So this is a payoff. Okay. And the worker without payoff, the firm without worker have zero payoff. So become Bertrand competition. Okay. So because the firm without worker would increase the wages to bid for the worker. So it's become a Bertrand, right? So and then at the end, they would have the same base and updating, right? Because look at the education, they hold the same belief. So because it's a symmetric model, so that means that the wage, okay, will be the expected productivity. So the wage, it means that the wage is no longer a strategic variable, right? Because of the fact that, I mean, if your wage is lower, then they would not choose you, right? So that means that it's a single sender, right? They will not send different signal. So now let us look at, very often when you look at this game, you will see they look at the case of complete formation and compare it with incomplete formation, then you can see the losses. This is the very standard approach when you analyze this kind of game. Okay. And suppose when the firm can observe whether they're high or low, okay, that means that no one would be deceiving, right? So that means that the worker, right, if this is his education, then this would be his wage, because the eta, whether type is high or low, is well known. So if you're high type, right, then you earn this wage. If low type, you earn this wage. Okay. Okay. And the optimal education, okay. Because I know this, right, then I would choose the best education for each type, right? The high type has the best education and the low type. And the associated wage is this one, right? Then you can see this model will be efficient, right? Because no worker is going to get not useful education, right? So everything is a nice outcome there. Okay. So this is the best possible solution, right? Because you know what you do, right? You study until you can't study more, right? So here look at equilibrium. So let us look at the equilibrium that's simplest. Is look at pooling equilibrium. Why pooling is easiest? Because pooling, the belief is the same. So the model is easiest to solve. Usually it's the pooling equilibrium. Okay, you can see the first bullet point, right? If you only see the only one type of education, that means that your belief of their high or low type remain the same as Q, because you believe the Q of them are high. So you have the first point. And that means that if the wages offered by both firms, because only observe single education, will be followed by this. Okay, will be an average wage, right? Will be the average productivity, right? So because you can see this guy, the low wage can be the low productivity can be very low. So this wage WP can be very low, right? Indeed, that is actually what happened in Taiwan, right? Since 2000, basically everyone go to college, right? The college admission rate is above 90, I think it's 97. So everyone go to college. So basically that means that average college graduate is earning very little amount of money, right? I think they call it 18K is it's like 18,000 Taiwan dollar. So it means something like 4,000 or 5,000 Hong Kong dollar when you're college graduate. The reason is like this, right? Because of course there are people that are good, but right, if everyone go to college, then it purely means that, I mean, you can't distinguish, right, based on education, right? And this is the requirement 3 here. So now we look at what would be the belief, right? So how to support this? There are many types to support this. The easiest one is to see if you see someone who has education, not college. Suppose everyone should do college. If you see an high school student, then you would say he's low type. But it also means that if he has master's degree, you consider his low type. All right? Whether it's reasonable or not is another concern, but under our perfect Bayesian equilibrium, it's allowed, right? Because it's off equilibrium. You never observe this. So it means that any belief is fine, right? Because how to justify this? Remember, why we have a Bayes rule is to consider this as a game that played repeatedly, right? We play many, many times, and we observe many outcomes, right? After the game is over, we know confirmation about the game. And in that case, we can apply Bayes rule. That's how we learn, right? But in a game that actually everyone choose EP, right, in the past, there's nothing said about E is not equal to EP, right? So that's why there's no learning. So in our free requirement, there's no restriction, right? So in that case, it means that your wage offer, but the firm will be, if you EP, then it will be like this. If you are this one, then you offer this, right? So there's no firm can deviate from that one because this is what they believe, right? And then this is the best they can do, right? The sequential rationality there. And education, of course, must be either some level, right? Or the level that is maximizing the low type, okay? Okay, you can specify whatever you want, but this has to be also satisfy that as well. Okay. Now, in order to make sure that the low type do what we want, right? It must be the utility for pooling equilibrium, okay, must be higher, okay, than the case the low type do what they want, right? This is a optimal under confirmation, right? If low type do what they want, right, then because they will consider low type, right? So the only deviation, only low type, right? The low type, is it low type going to deviate, right? And then of course you can check whether high type will deviate, but this is implied by if low type doesn't deviate, right? Because high type deviate will also be considered low type. So as long as the low type doesn't want to deviate, then the high type also don't in this particular case. Okay, so I'm gonna check this one. If all satisfied, the existence is guaranteed. Okay, so the graph look like this. Okay, so this is not be linear, but we draw it linear. This is a productivity. Okay, the product they produce for the low type, right, increasing in the E, right, and this is the other one, right? Maybe I draw it here. Okay. Oh, didn't share the screen. Sorry. So you can see, right? This is the low type productivity, high type, right? And the only thing actually happening in the equilibrium is because everyone is choosing the same EP. The EP is whatever you like. You can choose whatever point. And this is the wage is given, right? And why this wage? Because this is the average level of here. Okay, and in equilibrium, this only observed, right? So when this is a equilibrium, it must be the case that low type don't want to deviate. Okay, that means that this indifference curve must be higher than that, right? Why indifference like this is because education, right? More education is worse, right? Higher wage is better, So the indifference curve is like this one, right? Because go up is good, go right is bad. So it must be, indifference curve must be the upward sloping. Is that clear, right? Is that clear, upward sloping? Because going up is happy for the worker, going right is not so happy. So, right, so it must be upward sloping. And as long as this satisfies, right, that is no problem, right? Because in this case, high type cannot do anything, right? The same idea, right? If he do anything, he will end up in here, this one as well. So we can check. This is the pooling equilibrium. Of course, you may say this is rather crazy because if you have very high education, then suppose maybe you should work more, okay? But it doesn't happen in equilibrium, so this is okay. Okay, but later you will see we add some refinement to the PBE, then you allow us to take out this one because we think this is not very realistic, right? To say if you see a people with master degree or PhD degree, then you still think they're low type, right? Later we argue that how to take out this kind of equilibrium there. Okay, but is that okay for the pooling equilibrium? So now we have to check the separating equilibrium, and turn out that this is rather complicated. You need to divide it into two separate cases or subcases. Okay, and the first subcases is the easier one. We said that, okay, in the complete formation, okay, the low type do what they want to do, okay, and he has no intention to pretend to be the high type, right? Because the high type is earning this wage and this cost, but his low type, he has paid more cost, right? Means that the low type don't want to mimic, right? Because this is what it get as a low type under complete formation, right? This is if you replace by H, this high type, but you pretend, right? And if the other case is opposite, right, is the low type want to pretend to be high type, okay? So these are the two different cases, and you will see the analysis is slightly different, okay? But more or less very similar, okay? So this no NV case, what does that mean? It means that the indifference curve, right, is like here, it's like here, right? So in the remember when the complete information case is exactly like this, right? Complete information will be the low type will obtain this is a wage, the high type will this is the type, this is the complete information solution, right? And because this complete observed, there will be two different wages, because I know what is the type. It's a type dependent offer, but now we can't observe the type, right? So the firm is only allowed to give offer based on education, right? So now we say separate equilibrium, which means that this is the NV case, just before you go. NV case means that the indifference curve go inside, include the I type this one. But anyway, you will see later, you will see this graph is very important. Okay. So when we have no NV case, that's very simple, right? We can basically affirm it's very normal, right? I know that the low type don't want to make a high type, right? Why don't we have the why don't we just have the candidate where the low type choose the optimal, high type choose optimal, then they separate, right? Because the low type don't want to be the high type, right? Right? The high type can, because in this case, right, people who are low type do the undergrad, people who are high type do the PhD, right? And then low type don't want to do PhD, right? And PhD, of course, don't want to. High type want to do a PhD, right? It's higher wages. Yeah. And how to support this PPE, right? It's very simple. When you see people have PhD or postdoc even more, you think the high type, otherwise low type, right? Very simple, right? And then That means that if you see people have more than equal to PhD, then you give high type wage, low type. This is sequential rationality, right? And the education is just we said, right? The low type get the optimal what he's supposed to do, and the high type is a complete information outcome, right? And you see, because there's no conflict about the information, right? In this equilibrium, actually, it's pretty efficient, right? Compared to the pooling equilibrium, right? Because pooling equilibrium, everyone is not getting the optimal education level. But in this one, everyone is very happy, right? Because you separate them, right? So that is actually mean that in this particular case, right, there's no mimicking would happen, right? And it means that unobservable type is not a big deal, right? Education is successfully separated, right? So if you have this, is the wage is following the red line, and you have to jump to the 1, and then the belief will be 0 and jump to 1. Okay, so this is very simple. We're getting the degree, right? In the PhD is actually telling you the high type, and that's it, right? And this is very good outcome, right? Because as I said, this implement the first best, right? There's no problem with that. Right? Compared to pooling is not the first best, right? I mean, the low type get too little education, too much education. The high type get too little, right? But this one is the best, okay? But of course, this is too good to be best, because usually this is not the case, right? Because usually the case is the NV case, right? The no NV case is very simple, but it doesn't pose a problem, because even though I don't know who you are, but the low type don't want to be the high type, so you separate by themselves. So they really separate them. This is low type, this is high type, right? Then we're done, right? So you can see education in this model by itself is very useful in terms of increasing productivity. But on the other hand, it's also serving the information filtering, right? It's like you have, although the firm cannot tell, but by full education system, I can tell, right? There's some screening goes on here, right? So it's very nice. Okay. So here is slightly a little bit more complicated, okay? And a natural solution when you have NV case, right, is to allow the low type to do what they want to do, okay? But you don't allow the high type, okay? You ask the high type to do more, right? The reason is being that is education is more costly for the low type, right? So by what we call the involution, right? It's called Neigen, right? We gen more, right? We do more than what we should, right? We just try to make sure that the low type cannot follow, right? And that actually somehow explain why first class ticket for the airline is so expensive, right? Or business class is so expensive, right? Why? Because you want to separate from them, right? You don't want to be them, right? Or why very often in China, right? There's the way they design their zoning is like the whole area is put a wall there. You can't go in, right? It doesn't happen in other places in the world, right? It's there's probably only few things in China or in Mexico or some other country, right? Because you worry about things, so that's why you separate them. You have a high cost, right, to be there, right? So you can separate people out, increase cost so that you cannot mimic, right? So that's the model, right? So low type, they can't prevent them. You can just let them do what they want, because they can always do what they want, right? So that's why it's no point to ask them to do other than the efficient one, right? Of course, they can do more education or less, right? But increase their wage, then you must be E star, right? That's the very natural solution, right? And you ask them to do that, right? For equilibrium, must be the case that the low type don't want to mimic the high type, right? So the high type will obtain education until that low type don't want to mimic. Okay, so that's why these days, right, for PhD program, right, people do postdoc, people do pre-doc, right? People do another postdoc, right? People do more pre-doc, as many as they want, right? So that's why usually, right, the PhD was like 4 years, now it's 5 years, and people now do 2-year pre-doc, right? And maybe do one more postdoc and another postdoc, right? So it becomes like this. It happens, right? Not in econ and business, but it was happening before very easily in science and engineering, right? And right, because in science and engineering, the doctoral student is usually doing some experiment, right? And serve as a similar to lab technician. In that case, right, is low type and high type is not easy to distinguish, right? So you really need to separate them. That means that you need to increase the effort to optimal level. So here you can see the problem of this is you have overeducation in the society, right? People actually have more education than they need, right? So anyway, it's very similar to the idea that where you can imagine for those who are doing environmental thing, right? If you say the low type is very easy to pretend to be high type, right? The type is dirty firm is easily to pretend to be clean firm. In that case, right, the clean firm would over-invest in the clean production, right? Right. This is what it's supposed to mean, right? But anyway, you know what I'm saying because it can apply to many different scenarios. Or if an audit of finance, right, the bad firm can easily pretend to be good firm. Then good firm will have to spend extra effort to signal they're good firm. So this is the somewhat idea there. Okay. Or that means that's why a lot of firms spending a lot of money to do advertising, right? It's this same idea there. Okay. Anyway, in that case, you see this education level. There's 1, otherwise 0. Then everything is same, right? So there's nothing where DPA everything follow, right? The W would follow the mu because it's expected productivity, and this education level, right, is given by that one. And then it easily can be seen from the graph, right? Will be seen like this, right? You have a increasing productivity goes up, right? And jump up to here and all the way up, right? And this is the place where this indifference curve cut directly here, right? This is a place where the low type don't want to mimic. So it's easy, I mean, easy to see, right? By looking at indifference curve, you can know how to draw it. So that's why the indifference curve is very useful. Once you draw it, you know the answer, right? Basically, this must be this point, right? And here, right? So that would be the case. But this is the only one of the PBE, right? Because potentially it can be higher, also fine, right? It can be higher and the belief move a little bit, it's also fine. So you can have, this is the, I think it's the, one of the most efficient among the separating equilibrium, right? You can have more wasteful separating equilibrium, right? Where people actually go into extreme, right? They will go all the way up, right? Even more education, right? That's still fine. Okay. So these are the 3 different cases, right? We have the pooling equilibrium that is rather uninteresting because everyone do the same, which usually not the case, right? Because if you're high type, you want to separate, right? You don't want to pool together, right? So we're very strong in terms of high type to try to tell are not the same, right? Otherwise, you got a not so good treatment, right? So you would try to not the same, right? Because this is the same as just like a woman, right? Who think that every man are bad, right? And then you want to know more about her, you try to convince her this is not the case, right? But you have to keep the belief that every man are bad. There's no way you can convince her, right? So you have to put extra effort, right? to say I am a good guy, right? So that is the that is the way, right, to try to convince. Now here, which we said that we think this standard perfect Bayesian equilibrium is not sufficient, and indeed the literature there's a lot of discussion on how to improve them. Okay, I will talk about there are many refinements in the literature. Okay, I follow the book to focus on 2 of them. Okay, and I think that is often used, but do note that there are many types of refinement. You can check the textbook. They show you many types. One of them I think is pretty easy to see, although the math looks crazy. Okay, let's read slowly by that. Okay, we're looking off equilibrium. On equilibrium we can't do anything, right? Off equilibrium we say something. Okay, we say M. Okay, message is dominate for particular type T. Okay, if I send this message, okay, if I'm expecting sending message, the max I can get is less than the minimum I can get for the other message I'm going to send, then I will never send this M. Okay, let me repeat the statement. Okay, little bit, the notation was a little bit not easy to read, but let's read again. Okay, when I say M, why would never I want to send M message? M is dominate, right? Or think of the best case scenario. Okay, if I send this, what's the best I can expect in equilibrium? What best I can expect, right? The best I can expect is A tilde. Okay, and the worst I can get if I send another message, okay, is higher than the worst case. So the worst case is better than the best case. Okay, then I should never do it. Right? So that means that if something is dominated, okay, I shouldn't believe that this type would exist. Okay, so do know that I just refinement on the belief. Okay, not anything, just the belief. Okay, I don't allow belief arbitrary for off equilibrium path, right? But I just allow the receiver to be smarter, right? Think twice, think a little bit ahead. If I think, okay, I got a message. Even this guy sent me this message. If this message, the worst case scenario, okay, is better than the best case scenario, right? Then this type cannot be happening. Okay, so that would be the idea, right? I shouldn't believe this is I have something crazy, right? Then it shouldn't be the case. Let's suppose, like, simple in this way. Let's suppose a man and woman. Okay, a woman is a receiver, the boy is a sender, right? If the boy send her a very, very, very expensive flower, right? Which is, of course, is the flower will lose value in one day, right? And then in case it's so costly, right? Then in that case, they shouldn't believe that he is very poor, right? Because after he send this flower, what expensive diamond, right? He go into debt, right? If he's not that rich, then basically he just, like suicide, right? Financially, right? So in that case, then try to believe that it must be true. Okay, so it's so costly. I send a message. It's so costly. It couldn't be possible that I'm that type. Okay, let's see how this being applied. Then you will see. It's hard to describe in the math, but let's see the case. Okay, so the argument is rather simple. Okay, and it will kill the equilibrium that is inefficient for the high type. Okay, so remember the low type. Okay, the indifference curve is like this. Okay, in this one like this, right? So as I argue already, it is possible for some equilibriums like this, right? There's an equilibrium like this is also possible. Okay, this is also possible. Okay, and this equilibrium possible. We're trying to say that refinement we impose would kill this equilibrium. Okay? The idea is very simple. Low type, if he obtained more than ES, right? Why would he do that? He is better off by going back to there, right? But there's no point of doing that. Even if the best case scenario is offered by that wage, it can't be better, right? So it must be the case that when I see a guy who has bigger than ES, it must be high type. It can't be low type. Let me repeat the statement. Okay. I look at a guy who do many postdoc. Okay. Because if he's low type, if he's a postdoc, why don't he just do the bachelor and go and work, right? There's no point keeping staying in school, right? Suffer the PhD, suffer writing thesis, do many postdoc. There's no point, right? So that means that, okay, when I see a postdoc, right, it must be high type, right? It can't be otherwise. He just go back, right? Go to or if he thinks he has a no cut for research, he should go to industry, right? After finish his PhD, he should go to work for the government, work for the industry, not stay in academia, right? Because postdoc salary is very low, right? You stay for 3 years, doing nothing, right? Maybe doing something, research, waiting for R&R, waiting for rejection, right? So on and so forth, right? So you don't really doing that. So it must be the case that this is not possible. This is not possible. This must be 1. Okay, so that is the argument. Is that clear? So that would be the argument that I'm doing here. Okay, so the low type would get this, right? So you can easily prove because I already showed you, right? Because it's beyond the indifference curve, right? So it must be the case that doing low type already is better than everything above ES. Okay. So this is the first thing we remove. The second thing we remove is pooling equilibria. Okay. And you will remove pooling equilibrium such that, okay, the pooling, okay, the high type of this is higher than the pooling. So let me go back to the statement here. So pooling is like this, right? So this is the wedge here, right? And WS is this guy. It's an ES, right? Okay. And what we say is, look at the statement. Okay. The high type, look at this one. The payoff of that is higher than that. Okay. It means that if, okay, where we are. Okay. Look at the high type indifference curve. Okay. Depend on high type indifference curve. If the high type indifference curve is like this, sorry, it's high, right? So this is better, right? So for the high type, this is better than here. Okay. And in this equilibrium, this got killed, right? Because this must be high type, right? So you will do somewhere here, then they will got it, then they will kill this equilibrium. Is that clear? Is that okay? Is that okay? Because if you impose a refinement, right, this cannot be 0, right? This must be 1 here. I don't know how to where one is here, right? Suppose one is here, one is here, right? So the salary must offer in this one. So you can no longer offer this salary, so this is gone, right? But in that case, this is better than this one, so it killed the pooling equilibrium. The high type will pretend to be, high type will deviate from the EP. We'll get anything above, anything in the range would be the deviation. Is that clear? Is that okay? So this refinement alone actually kill a lot of pooling, right? Because pooling can be a lot of stuff, right? There are many things they can pool, but we say that a lot of pooling can be killed, right? But still, we are not happy enough because we still think pooling is very inefficient, right? Because we think if everyone got the same, right, because still there's a lot of pooling there, right? And it's not something that we expect for market to do, right? Because the market should segment, right? Most of the time, right? So let's see if the market is efficient, right? If you use the finance idea, right? If you think the market is efficient, right? You should be able to, the market is smart enough, okay? Oh, this is already the graph here, okay? So the separating is only separating like this, right? Oh, this is the pooling equilibrium as I mentioned, right? If beyond that, it will be 1, right? But then it will be not acceptable. And only equilibriums like this kind of pooling equilibrium, right? Because when you draw the IH, right, it's like here, right? So this is not better than this one. Okay, so pooling is still better than that one. So already have the graph. Sorry, I should talk about this graph rather than jump over there. Okay. Now, last one, of course, is one of the most famous one. Is called the intuitive criteria. I think is the one of the most there are many, but this is one of the most famous refinement. Okay, so the idea is very similar to what we have, but even more sophisticated. Okay, is we call equilibrium domination. Okay, and here is the same idea there. Okay, we have a message in the maximum. All right, so I consider MJ is dominated. I consider the best case scenario if I send this message for this type. Okay, but what I change the left hand side, I weakened it. Okay, remember what I have in the left hand side before is the minimum. Right, just go back in case you do not get it because it's very important. Right, this side the same. Right, this is no longer minimum. I don't require the minimum. I replace by weaker one. I will replace equilibrium payoff. Okay. So that is a weakening of what we just said. Okay, weaken this part to the equilibrium for type T. Right, for this type in equilibrium, I send this is less than that, then this type is not possible, right? Because as I said, is suppose I'm TI, right? If I send this message, the best thing I can get cannot be better than what I get in equilibrium, right? So this type is not possible, right? But of course, this is a much more demanding because you have to know equilibrium payoff, right? Before I don't require equilibrium, right? Here I have to require equilibrium. Okay. So, and intuitive criterion, that means very intuitive. Okay, I don't know whether you agree with the term, but that's called intuitive, saying that if that's the case, it was 0. Okay, so let's see the example, because I think for you, for this one is no matter how many times you read it, it's very confusing. Let's see the example in practice, then you see what's going on. Okay, so let's try to argue that all the pooling equilibrium will die. Okay, so let's see the following, although looks pretty crazy here. So let's make ourselves easy. Okay, is to look at this pooling equilibrium, right? This is the Q, right? And this L you have here, right? This is the part, this is the point. And because in the domination, we have that one as well, right? And this will be here. Okay, so that is the original pooling equilibrium, right? So the orange one are the standard one, right? And this is coming from the refinement from domination. Okay, so now we argue that the intuitive criteria will impose this guy. Will impose the green one. Okay. So how do we argue why green is also 1 there? Okay. So what does it? Why is the case? Now consider the case you're low type, right? You're here, right? So if you're low type, you have no intention to do more than E prime. So suppose you are the low type, you are obtaining your EP is equilibrium, right? Look at the indifference curve. Let me draw it again. The indifference curve like this one. Your indifference curve is this guy, right? So anything that in the right-hand side of the pink curve is bad, right? Is that okay? Any outcome that is on the right of pink is no better than the red dot, right? Red dot is what you get now, right? Indifference curve, right? So suppose, okay, you're going to be here. Will you do it? No, right? Because it's below indifference curve, right? So even though you get this education, you get the high salary because it's a maximum salary you can get, right? You will not do it, right? So when you see the education is between E and E double prime, okay, it must be the case that it must be the high type. It cannot be low type. Is that clear? Then let me repeat because I think this is very important because how to solve this model, right? So we have red dot here. This is the pooling equilibrium outcome. Okay, we had to argue that you cannot assign 0 here, right? The reason being that you draw indifference curves passing through this pooling equilibrium, all right? And it must then that means that the indifference curve means that the low type would be happy to remain in the pink or above, right? That's what indifference curve means, right? And if your offer is here, right? Suppose you get this education, you're given this wage, you will not be happy, right? Because that is what indifference curve is supposed to be, right? So you're happy in equilibrium, you are here, right? So there's no one in equilibrium, no type. If everyone is here, if you see a education in this one, it cannot be a low type, right? Because low type is happy is in the pooling equilibrium. Does it make sense? Okay. So when you see this, within this one must be 1. Okay. So that is but if this is 1, this is this case, then high type will not be doing this one rather than it will do it there. So this equilibrium, the pooling equilibrium is killed in this one. The idea again is very simple, right? If the pooling, right, because single crossing or this is the high type must be flatter in this way, right? That means that it must be the case that there exists some range, right? High type would want to do, but low type don't want, right? And that means that they could just do as well, like slightly more than the pooling level, such that low type don't want to mimic. Okay. and only the high type want to do it. And if the firm is sophisticated, knowing that if pooling at that level, low type will have no incentive to do that. But then the high type can actually just do it, and then we'll be done, right? Just like here is the pooling at the undergraduate, right? And here I go to master level, right? The low type don't want to do master, don't want to have one more year, right? And in that case, then he can just do it to distinguish them. Okay, is that clear? Is that okay? Okay. So this is come to the very last slide, okay, of I just keep it there. So that marks the end of the game theory, the second part of our course. Okay, so for remaining two hours and also the next class, we would cover something that in addition to what we're covering. So we cover some concept theory. You have time, we cover something like bargaining, other models. Okay, but today we'll cover concept theory. But you can see this type of model is very complicated, to be honest, right? This is already this, I think it's the most simplest you can see. If you have this one of the simplest you can see if you look at the literature. And the literature, they are so complicated to analysis. So that's why we often, in this case, look at the pooling equilibrium, right? Just one guy have information and send it out, right? It's easy, right? And of course, the other way to go when you really want to apply this is to discretize, right? We have seen in the example of the signaling game, if this is discrete like this, right, then you only allow, instead of allowing education is continuous, right? If you focus on the case where they only allow left or right, right, then you can solve the model rather easily, even though you allow the receiver to be continuous, right? As long as this is discrete, right, you can easily solve it. You can maybe not allow left or right. You can allow high, middle, low. Then you can achieve the same idea, right? Because continuity, right? That thing is like try to extend things, right? Everything will be binary. Will be a lot of things actually. The intuition goes forward. Of course, when you have more than two, then things can be complicated, right? But same as like, and later we'll talk about concept theory. We'll talk about things in many things binary, okay? And because most of the intuition actually happens in the binary case, right? More than two, it's good to have. If you can solve it, but when you really build your own model, it's okay to remain at two, right? Because already this model can be complicated. Because very often you don't use it by themselves, right? You mix it with other ingredient, and that model is already very complicated, right? So I hope the answer the question. Okay. So let's a break. After the break, we will come back to concept theory. I guess since this is we are done with the maybe we do some you reply, I guess, right? If let you ask some question in case you want to ask and you are afraid to ask. So just some question. In case you want to ask something, then please leave your message here so that we know what you want to talk more and then what the question. So let's break for 15 minutes. We come back. every end of semester. No more class already. It's already free of the class. So you can take whatever you like. I will take some as well. Yes, after now is you can relax because everything is just part of the fun. How to make that. This is more important. Non-teaching for example, much more. Even though the IT,
可以放我去年的就好了，如果要提的话。So in the break, someone asked me to upload the last year exam. Last year's take-home exam, so you can check what I'm asking last time. But as general practice, I'm not releasing any solution to that one. But I think you can easily figure out the solution, right, by yourself. Shouldn't be something too difficult. Or you can ask last year student. I think most of them correct. So you ask them what they have answered, then will be your solution. Okay, then shouldn't be, because they do it it's take home, right? So they have all the solution on their hand. So you can just ask them. It's not for me, but you can see the questions like something like consumer, the producer, and the uncertainty. There's not game theory, normal form game, and then application. Okay, more or less similar, but maybe I'm just bored by having similar question these years. I may probably make up something new, but other than that, should be somewhat along that line. Right? So maybe 3 to 4 questions and something like that. Okay, so should be very applied. So shouldn't be, there's no proof, right? Basically all the computational thing. Okay. So there's nothing very deep in this one. So there's no further question. Then let's look at the you reply in case any of you have say something, or if nothing, then it's the best. Or some at least 2 information on the project. So you can do whatever you like, as I said, right? It's an open-ended assignment. So either you can do literature review about theory, right? So you pick up some theory paper in your field, look at the frontier, several paper, and just discuss a little bit, it'll be fine. No, just theory, right? You apply game theory there is fine, right? Microeconomic theory is there, right? So I guess most of things is within this range, right? People are maximizing utility, right? That's something, I mean, it's hard to think about anything more than it's not doing something like this, right? Even macro fall in this idea, right? So I think it's hard to be away from that, right? Whatever that is relevant to be there, right? Yes. I don't think you can review empirical paper. Anything about theory, you can just review. Or you can write your own model, right? Or write a model, it's fine.
or modify the existing model, also fine. So it's up to you how much effort you put in. I'm indifferent, but of course, I can tell how much effort you put in the project. Right? Is that clear? Okay. Or you have been working on something already, you can just put them as well, right? Of course, should be relevant to the tools I used in the class, right? If you use, say, stochastic process, which we don't cover, that may not be the best, right? Put something at least somewhat relevant, right? Something relevant, game theory or something, or concept theory also fine, right? Within the scope of what we are learning, right? Environmental also fine, doesn't really matter. So it's very liberal. I mean, in the case you are worried about it, you can email me. I can tell you whether it's within or not. But in general, it's okay. I think microeconomic theory is basically the thing that we use for throughout the methodology used in B school, right? So those in case there's a other one is called describe the knowledge of final test. It will be up to now. You can see the past paper, 8 chapters, and that's it. Okay, and there's actually the core microeconomic theory, right? It's the game theory, as well as the standard market solution, choice uncertainty there, right? So I think that would be the question. In case you want to ask, that would be the case. So I guess this is no one answered that question. And the very last, I think it's easy. If you look at the exam paper I gave last time. Okay, so someone asked me, you can just look at the blackboard that would be there. Okay, so then be too complicated. And I guess there's no question from you, so we can now sit back and relax. This final exam is already on the IV in the blackboard. So feel free to get candy if you want, because we're now more or less relaxed. Because from now on, it's like try to learn something new, and try to hope that it will be. I think this is very useful in Actuarial B school. It's about concept theory, and you can see that a lot of time you can learn it. That will be a useful tools that to learn. Okay, and we'll start with the lemon market, average selection, and with mechanism design. I think we have 102 pages. So I think luckily we finished everything, but if not, that should be okay. Okay, I think the material here is sufficient for the remaining 4 to 5 hours. Okay, I will be brief. Very brief here is the lemon market. Trying to say that information asymmetry will kill the market. Probably everyone knows it from undergrad, right? The lemon market. But here we just try to show you some math to justify what's going on there. We're looking at the standard model by Aklov. This is everything actually followed from his, I think, RES or QJE paper. Okay. And in the jargon in the US, right? Second-hand car, they're good, they got peach. The bad, they call lemon. Okay. And that's why the lemon market is that the second-hand market turned out to be a bad car. But you don't know it in advance because only the owner knows how good or bad it is, right? And as a buyer, only if you can try, you know whether it's good or bad. Okay. So the seller have more information on the car, right? And then the problem is information asymmetry. Selling it rather than keeping the car, right? It does imply that you value the car less than the price you like to sell, right? It does say something, right? To send some signal. So that is a problem here. So let's look at the example, and this example I think is in the paper. So I just follow closely to the paper as close as possible. So here they mentioned the two type of car, okay, and you can see the good car and bad car is so separated. Right? Good car is 9, the seller worth 90, buyers 100. Bad car, the seller think 10, the buyer buy 20. Right? Then in this model, if I know what is good car, what is bad car, then the model being solved, and good car being sold, and bad car also being sold. Right? There's no problem. If I know who has a bad car and who has a good car, right, that can be sold, no problem, right? And that is not a problem even both sides doesn't know the value of the car, right? So in this case, right, to make it simple, make the supply of car is finite, demand for car infinite, and that why we do that, because we set the price equal to margin to be paid. That simplify our problem of bargaining, right? And if you want to relax, that's not a big deal. The idea still holds. So in this case, and if both sides know their car, right, and then you can see, right, because demand infinite, right? So good car is sold 100. Everyone want to buy 100, and the bad car sold 20. That's no problem. And if both sides have no idea about quality, that's also fine, right? Then the price is set expected valuation from the buyer side, 60, right? And because buyer doesn't know and seller doesn't know, then 60, everyone's happy, right? Everyone's getting what they want, right? Because the seller, right, on average, they value the car as it's 50, right? Half of the 90 and half of 10 is 50. So it's selling 60, it's okay, right? And the buyer this is the marginal price, right? So no matter what, right, regardless of the buyer know, the seller doesn't or not, as long as their information is symmetric, okay, there's no problem at all. The only problem is some of them has information and some of them doesn't, right? So that is the idea, asymmetric information. And because asymmetric information, only one price is possible. Okay. So you can look at the case where price is more than 90, okay? And in the case, if the market price is 90, both type of car were being sold, right? But in that case, buyer cannot pay more than 60. And if you know your car is good, you not sell, because you value the car $90. Only 60, then will be there. So it cannot be equilibrium. And if the price is less than 90, that means that you, as a person who had a good car, will not sell it, right? And that is not possible, right? You will only keep it, right? So in that case, this is only equilibrium, right? Only sold at $20, right? And only bad car there, right? That is usually what we call the bad money drive good money, right? 利弊驱逐良币, right? That's what actually this from more or less from this one, right? Because the existence of bad thing actually drive out good thing, right? So that's only lemon cars are traded, right? And the good car are not traded, okay? Or at least they would have a club or there's something to forbid them to. But it's like pulling equilibrium, right? Because the bad type can pretend to be good, right? There's only one price, because using price as a signal, it's not one signal, but you're two type of information. So for sure you will die. So let us make a formal model, right? Because so far we have a numbers. So let's say make a numbers. So we have many sellers and many buyers, right? Each value Q. The seller is n plus Q. The buyer is n plus 1.5 Q. Okay. And the Q is uniformly distributed from 0 to 100. So what we want is to look at
the market. Okay.
And as we see, under symmetric information, everybody know the car is only 1.5 Q as we see, right? If otherwise, they would seal at the expected quality, right? Because it's 0 from 100, right? So it's 1.5 is expected quality 75. Okay, so that would be the idea here. Now the next part is asymmetric information. Okay, would argue that in this particular case, when we have continuum of quality, in the discrete case, we have only bad car in the market. But when you have quality is continuum, turn out to be the market completely breaks down. Even the market with bad car will not exist. So complete market collapse. Okay. And do remember how market works rely on a price, right? Decentralized in such a way that everyone look at the price, they coordinate through the price. And because of the information asymmetry, this price lose its ability to regulate the market. Okay, actually, let's see. Suppose the price is 100, right? And then everyone wants to sell the car, right? So the quality from the market will be 0 to 100, right? The average quality is 50, right? So that means that people are willing to pay 75, right? Because 1.5 Q. That means that if your car has quality is more than 75, you are not in the market, right? So that means that this is not possible. So let's go down. Let's shrink the market to 80. And again, average is 40, only pay 60. So go down one more, if you're 60, right? And average is 30, people only need to pay 35. So the gap is getting smaller, right? You reduce it's getting smaller, right? Because the gap is 25 here, the gap is 20 here, this gap is 15. So it keeps shrinking. And what you want is look at average quality times 1.5. This is how much buyer want to pay, right? The average quality times 1.5 is the worth to pay for the buyer. Okay? And this must be the price, right? Because only this amount of car being sold, right? If this price is P star, only this car being in the market and this people want to pay, and it must be equal to the price star, right? Because that is what the buyer would buy, right? But in this case, you can do the because this is uniform, right? Up to P star, right? This is the distribution, right? And easily, if you put P star equal to this, right? P star must be 0, right? Because P star equal to 0.75 P star, right? The only solution is 0. That means that only the case price is 0 is achievable. Okay, that means that there's no car being sold, right? Because you want 0.75 P star equal to here, right? So P star must be 0. There's nothing you can do. So of course, this is an artifact of this range is too large, right? So why you have equilibrium in discrete case? It's because the low quality is too low here. If low quality is not that low, say low quality is instead of 0 to 100, you run from 20 to 100. That means that by changing this means that the information asymmetry is not that severe, right? So of course, you can easily see when you increase the lower bound of 20 to 80 or 90, market always exists. That's no problem. Okay. So now if you do that, do the same procedure, but now uniform between 20 to 100 will be P star minus 20 because they say uniform there because now the uniform is like this. If you let me draw a picture, but I guess you guys are PhD, shouldn't be an issue there, right? This Q, right? You have P star. You have 20 here, right? And uniform between 0 to 100, right? So the height is 80, right? 1/80, right? So you're looking at this stuff, right? So that's why you have to do the conditional statement, right? You replace it by this become here, right? Uniform. So the conditional become higher because area must be 1, right? So it will be go up, right? The height will be P star minus 20, right? So that's how you get this guy, right? Integrate. And you want this, right? Expected quality, the same as the price there, right? Because this is price being sold. And you can solve, right? On 0 to 5, P star equal 15, then P star is 60, right? So which gives you the same idea as we have seen, the simple example where quality that is below 60 is there, but above 60 is gone. So it gives you the general idea why this hold. Okay, and this is exactly in the book. Sorry, in the paper by Akloff. Okay, so I just. But you look with the paper, so basically he skipped all the calculation, right? Just show you the answer. So I put it all there in case you want to read the original paper. So everything is there. Okay, there's no. I don't think I skip any part, right? So you can check out rather easily. So now once we have that, we have actually looked at the model. We have 2 ways to do communication. Okay. The first one actually we just study is signaling, right? So signaling is the guy who have information to move first, right? Who tell you that okay, we are good. Okay. So that would be the idea. Okay, that is something we have done, right? Education is a signaling. Another is called screening. Okay, screening is actually usually in the business ideas the insurance contract, right? And you look at for health or car insurance, they will usually give you different coverage with different price, right? Low coverage, lower price. High coverage is very expensive. Why? Because the problem is you don't insurance company don't know they're sick or not, right? So healthy people likely to do not need so much insurance, so the low coverage will be cheap. Unhealthy people will be likely to require full coverage, so that will be more expensive. By allowing the insurance company to set up a menu of contracts, so they offer different price or price discrimination, they let them self-select. Okay, so that is actually that's what we do in contract theory, right? Is you design a contract, let them sign up. Okay, and we already done the screening, right? Signaling, so that's fine. So contract theory is more or less the screening, more or less like the screening idea. Okay, and but we still look at some signaling in this framework because it's also fun to look at signaling because it is interesting to look at what we call the verifiable signal. Okay, so the one we did just before the break is called not verifiable. It's called costly signal, but this is verifiable, which means that if I spend $15 at a shop, I can certify my car is good, right? They check everything, everything's all right. I spend the money. So let's see what we will observe. Of course, you expect this is also a cost signal. It's very similar to the one, right? But here is once I certify, I know the car directly. So it's, but the idea is same, right? Only the high type want to want to do the signaling, right? The low type don't want to because it's costly. So the question is, how does it change the equilibrium we have just saw? Okay. So the idea, the first is, if your car quality is 20 to 30, right? Because it starts from 20, right? It's less than 30, and the profit of certify is only give you, because it's 15% of the quality, right? So 50% of 30 is less than 15, so you will not do any certification. Okay. And now let's start from 30 onward. Okay. So we focus on the following equilibrium, which we prove, you can prove to be a cutoff equilibrium, and that will be the, I think, the most reasonable one. And I think that is the, you can prove the unique one with the current setup. So how do we say? We impose the following condition. So there's a threshold such that if people are higher than that, I think I should change the strict equality sign. Okay. So when the Q is super large, you want to test it, okay? And less than that you don't, and the middle you would be indifferent, okay? And look at the guy who is indifferent, right? If then the right hand side is very easy, right? Look at this one, it's very simple, right? If I know my quality, right, by spending $15, I get 1.5 Q star minus, this is I certify. If I don't, that guy will be mixed with 20, the lower bound, right? Half of that is the average quality, right? Because uniform times 1.5, okay? And turn out to be this Q star is 40. So there will be equilibrium, which I think this cutoff equilibrium makes sense, right? Is for more than 40, they will test and sell at 1.5 Q. And those below 40, that will be test without test and sold at $45. All right. So that would be the simple model with test. Right. So they verify, right? Actually, that is what happened if those who are doing environmental thing, the marketing, right? That's what they do, right? A lot of firm, right? They try to tell them they are ESG certified, they are high quality, they are following fair trade, they're doing right thing, right? So that is the idea. Or look at the case where accounting, right? Why people spend money on top 4 rather than non-top 4, right? Top 4 is more expensive, right? The certified top 4, then people know they're high quality, right? Which may not be the case now, but anyway, suppose it's a old story, right? Because now we know even the PwC is doing something very bad, right? But this is why, right? People spend a lot of money on that, right? Because people believe that you can certify, at least everything is followed, right? And in this model, very good thing is when you have certification, every car got trade compared to the old case, right? Because when we don't have this technology, not every car got trade, right? Because the good car is not trade. But when you have this technology exists, okay? And that's very important to certify, okay? So actually this gives you the reason why in economics, right? A lot of people, government have some role or certification, third-party certification. It's very important to certify, right? In order to distinguish that, because no one can distinguish, right? So the accreditation is costly, right? Look at this system, right? As long as C is not too large, actually social welfare beneficial to do it, right? And right, in some sense, that's why you're here, right? Why you are here doing a PhD program is to costly verify you're good doing research, right? So in order to do a PhD, you spend a cost of 15, right? The same idea goes on. Is that okay? Now, once we are done with that, then I think we can now go into more fun part. We'll go into adverse selection model. Okay. And I think this is what we can do today. I mean, the more harsher we left, I think, next class and mechanism design. So probably, I think we can finish adverse selection today. Let's try. So in contract theory, usually there will be two types of model. I mean, of course, there are more than two, but mainly you will see adverse selection model harsher. And what are they? Okay. And remember, it's a principal agent problem. So the principal doesn't know some asymmetric information, right? There's something the agents know. And if I don't know the guy, what they would do is called moral hazard, right? Suppose I hire a guy, suppose a school is going to hire a researcher to do research, right? Or do some programming. You don't know that guy is doing or not, right? He may be just looking at Xiaohongshu or playing games, look at YouTube, right? Don't do anything, right? But you can't really check, right? So then it's a more hazard, right? So usually what in there is you know the output. If you can measure the output, you don't know the input, right? So you try to link your compensation to the output. Try to make sure that if you know how input transform the output, by making different payment to different output, you can make him do what you want. Okay, of course with some losses, but at least you can incentivize what to do. And adverse selection is what we just said. You don't know the guy whether he's a high type or low type. Okay, by offering different contract, okay, you allow low type to select the contract designed for them, right? Like the insurance contract. Or some of you later, after 3 or 4 years, when you go to job market, especially in some of the Chinese school, they will offer you 2 different contracts. They will say you get high salary contract if you get a journal published every 3 years. Okay, and they give you a salary reduction a little bit. If you think that you can do A every 3 years, you can have B 3 years. Or you can choose the safe contract. You get lower salary, but you immediately get into the system. So you get job guarantee. Okay? So by doing that, if you are confident, you're good, then you select the A contract, right? If you are not confident, you do the B contract, published in B journal is fine. If you are not really, if you are very risk averse, you go to C contract, published in Chinese journal, right? You're done, right? So that is the idea here, right? So actually it's not loving, it's actually there. It's actually this concept exists in China, right? Also, you know there's 2-tier system, right? Either you are 叫什么什么鬼 I forgot. There's somewhere, I mean, I forgot the name, but there's a 2-tier system. Anyway, so that is the main idea there. So let's a problem. So it's a principal agent problem. So the idea is because principal cannot do everything by himself, he has delegated tasks to the outside agent, right? It's actually they're opening the box of theory of firm, right? So far in the firm, there's nothing, just the firm produce what is producing what, right? So we don't open the box of the firm. So basically, theory of firm or contract theory is the most important building block for organizational economics. Or in finance, accounting is the same idea, right? Because what is bond, what is stock, is ownership, right? And the management is by manager, right? So it's how to design the corporate finance, how to finance them, right? Organizational economics is how we do, right? Also same as the outsourcing, supply chain, everything is there, right? But okay. So here is very simple. Production, I delegate Q to the outside, okay? And the firm will derive S of Q if this Q being produced, and S of 0 is nothing being produced, okay? So, and you can think Q is quantity or quality is fine, okay? You can reinterpret this as quality, all right? I ask the firm to produce 1 unit of good. I don't know the quality. Okay? So the problem here, what is the unobserved is not the quantity or quality, right? If that's the case, that would be something else. But what we don't know, because they can be observed, what we don't know is the marginal cost of that firm. Is the agent efficient or not efficient, right? Is the agent capable or not capable? We don't know. But of course, we want to choose capable one, but we don't really know, right? So once you hire, then you can't really do anything. So I can't know it's low cost or high cost. Okay, I just know with some probability that's low, with some probability that's high. Okay, and the cost of production for the agent will be a fixed cost plus linear to the quantity. Okay, it's fixed marginal cost. Okay, it's making it very simple. Okay, and here's very important parameter in the model turn out to be the deciding factor is the delta theta, right? Is the difference between high and low. If this is 0, then the model is done, right? There's no uncertainty here. Okay, and turn out this is really driving behind the model. Okay, and without loss of generality, we assume f is equal to 0, because that doesn't affect it just affect that the surplus, because if f is positive, you have to pay that guy f to make the production happen, right? So every payment just plus f, right? So there's nothing really deep there. That's why it's without loss of generality. Is that clear why without loss of generality? Because you have to pay f for that guy to produce, right? So that's why you really have to pay f. So that's why make 0 have no influence in our model. And to note that we have a very important restriction is linear cost. Okay, of course, there are more paper that will restrict that, relax that. And here the information asymmetry is only 2 types. You can generalize to more than 2, but the idea remains the same. Okay? Is that okay? So the setup. So here we say contract theory must be offered a contract, right? So we say it's like screening problem, right? So what we do is the firm have a contract, and turn out to be in this kind of model, it's very important what you put restriction on the contract you offer. So when we say the firm offer a contract to the agent, it means that the firm has all the bargaining power. Okay, and that if you follow the literature, they say that this is assumed without loss of generality, in a sense that this allows the firm has all bargaining power. That's why he can take a leave it offer. But if you allow firm has less bargaining power, you can just assume they split the surplus later. Okay, this is they cover the most efficient contract first, and then the lump sum payment will represent their bargaining power. Whether you buy this argument or not, I don't know, but this is what being argued in literature. Okay, so of course, if you think the firm is not the one with bargaining power, you can reverse it, make the agent offer, right? But in that case, agent know what they're doing, so the problem doesn't exist anymore. But anyway, the contract is the following. We specify the quantity which we can observe, and for each quantity produced, what's the payment? Okay. So it's a contract, a function, right? Or a pair. For each quantity, I tell you what price I'll pay, and then I have no restriction on the payment to be positive or negative. Okay. So that is no restriction, right? And do note that this is, you allow this may not be a general thing, right? Because sometimes you are not allowed to extract money from the guy, and turn out to be this is an important restriction, right? If you put that, the model will be very different. So later you will see whether you allow limited liability, right? Will be important thing. But for the moment, I can extract as many as I want, right? So then now let's see the model is usually you see the 4-stage game. I don't have the picture here, but usually you will see a line like this. Okay. T equal 1, 0, T equal 1, T equal 2, T equal 3, something like that. This is often I should have drawn it here, but usually this is shown in the paper, right? The first is the nature decide what the type is. Okay. Why you have to do that? Because we have to specify the contract, right? And then he know it, and the P make a contract offer, and A decide to accept or not. That is the contract theory. Assume all the power is in principle, and the contract being executed. Okay, so the contract is legally enforceable. Okay, so so there's no cheating in this model. You can relax that, but in this model we don't. So let's see the complete information model. That is turned out to be rather simple. Let's do it, and then we'll break, and then we talk about the main thing. Okay. So in this model, this is the surplus, right? And it must be the case that the payment must able to cover the cost. All right. So that's why we said F is 0, has no loss of generality, right? And if I can observe the type, okay, then the principal can then offer such that it's type dependent, right? I know the type. Okay. So it's very simple. If you're low type, the marginal payment is same as the marginal cost, right? MR equal to MC, right? So the P equal to MC, right? So that will be efficient, right? And in that case, you can, what is social surplus, right? Will be the total money earned minus the payment, right? And you can easily prove that if it is a low type, the social surplus is higher than the case when it's high type. Okay. So and the low cost optimal production level higher than the high cost, right? And the surplus also, oh, sorry, this is 0 here. I think I missed the 0, this. Right. Okay, so that would be the idea here, okay? The 0 here. Or, yeah. Is that okay? Is that okay? Because S, right, is linear. So that is the first model. Okay. So how do you try to solve for the incomplete information? Okay. Maybe let me mention this and we'll tell the solution there, but that is the setup. We can think about that in the break. So the idea what we end today will be the following. So we are not going to able to know how high cost or low cost they are. So what we're going to do is we'll specify 2 particular contracts, okay, with low under bar Q and T under bar, which specify for the low cost producer. This is the payment I gave, and the high type production and the high type payment. So for each type, I specify how much you want to produce and what will the payment I give you. Okay, such that they're happy to take what they want. This will be a constraint we do. Okay, and because under low type this is the low type surplus, high type surplus. So the firm is going to maximize this expected surplus. Okay, and that's what we want. And then we will tell you that for them to be chosen, this will what we call the incentive competitive constraint. So we have 2 contracts. So we actually need to make sure that the contract designed for low type will be chosen by low type. The contract designed for high type, chosen the high type. Okay, they do what we want. Okay, and they don't want to swap. Okay, and of course, also the other constraint we will see is called the IR constraint, individual rational constraint, or what we call the participation constraint, which means that they rather produce than do nothing. Usually, that is not a big deal. The main thing is the IC constraint mainly, right? And that will be we will do after the break. Okay, maybe we'll stop break today because I think we are very intensive. So in the meantime, let's a break of say 10 minutes, and feel free to take some candy because I guess we are already done with our class. We can celebrate a bit. So we'll talk about how to maximize this after break. Let's have 10 minutes break. So basically, the firm is going to maximize, continue what we left is maximize this expected surplus under the contract, supposing that the guy, they do what we suppose ask them to do, right? Let them self-select. And for self-selection to happen, it must be the case that the low type choosing the low type contract better than the high type contract, right? That's why the IC lower. So they do what they do, and they do something not supposed to do, right? And this is for low type, and same with high type, right? That's called incentive compatibility, right? These appear in all mechanism design or contract, right? So the low type do what they supposed to do. Okay? Actually, the same as very similar to this, very similar to the signaling game we saw, right? The high type don't want to mimic the low type, so very similar. The pooling because the firm want to induce a separating equilibrium, so very similar, right? And do know that only 2 contracts needed, right? You don't need other 2 contracts. You don't need more than 2 because only 2 types. You need as many types as you want. So sometimes this is called the participation constraint or individual rational or individual rationality. It's saying that we will specify outside option, which normalize to 0 because that guy can do nothing, right? So we normalize 0 here because this should be F if you don't want to, if you did not normalize the fixed cost, right? So it will be the case that the payment over the variable cost should cover the fixed cost, right? But we set F normalized to 0, so that means that low type non-zero and this non-zero. Don't let that 0 who have fun, and your model can be changed according to this guy. Okay, because within the firms and principal agent, right, it may have 0 outside option, but the outside option is also determined by the whole market, right? So it's possible that it may not be 0. So you have to be very careful when you, and that part can be endogenous, but this is beyond the scope of today, but that's the part. So you can see that actually constraint theory is simply a constrained optimization problem, right? So there's nothing, although the term is very grand, right? But you look at every single proof there is basically optimization problem, right? Just solving constraint one. So basically what you do is you have a problem by choosing different constraint such that people choose what they're supposed to choose and they don't want to leave the system, right? And I see it telling that low type choose low type, not the high one. The high type choose high type, not the low one. Low type is happy what they're doing. Low type want to happy what they're doing, right? So, of course, actually, if you are working hard, you can actually solve this Lagrangian problem, right? It's not something because the S is a concave. It's a concave programming. So you can always solve this problem. Okay. But turn out there's a shortcut here is by looking at this, it's not easy to see how you can solve this problem easily. But I think if you look at the textbook, I said in the reference list is by whom? By Lafont. Okay, Lafont. So what they focus on is to rewrite this is the surplus for low type. This is surplus for high type. Okay. And we write this is the expected information range. Okay. This is what the agent can get, right? So if you write this way, you can easily see that, okay, the principle is maximizing the surplus minus this range, okay? And you write this, the IC constraint can be written as the range, low type is more than 0, high type more than 0, and the low type range is higher than the high type range plus delta theta, as we said delta theta is important, plus Q hat and delta theta minus Q hat. So we can rewrite that. Okay, there's some math behind, but you can easily check. Okay. So you may ask, how does it help we solve this model by rewriting? The answer is, look at the objective function. Now we are going to not the t, but u, right? And it's become clear you want to make u as small as possible, right? Either u hat bar or u lower bar, right? Because that is the cost to you. Okay. So what can we do? Okay. And you look at this one. This one is bigger than another, right? You want to make it 0. So which one you can make it 0? Right? So bigger than 0. If you make this 0 or make it this 0, which one is feasible? You can't make, can you make both 0? No, because you make this 0, this must be bigger than this guy, right? You make this 0, that's all fine, right? Because it's 0, if you make this 0, this is fine, right? So the best is you make this, right? This is how you can solve this, is by making u upper bar 0, right? Because you try to put u upper bar and lower bar to 0. Let me repeat the statement. How you can see this? Optimal. Because you are minimizing what the agent will get, right? Because you, agent and the principal are having the different in interest, okay? The lowest you can go is 0. Okay. And let's see, if everything goes to 0, then you're done, right? The simplest is to try the PC under bar, this thing hold, right? If this two thing hold, then actually you solve the problem. Can you do that? You put it 0, This is fine, no problem, right? 0 bigger than negative, fine. But when this one, 0 bigger than this doesn't hold, right? So contradiction. So U upper bar, right? So U lower bar cannot be 0 strictly, right? But when you put 0 here, right, you can minimize, will be equality there, right? So the only thing is binding is the fourth inequality and the first inequality, right? And once you have that, then you can see the other two are binding. Well, actually, that is also a way to solve this kind of complex problem when you solve concept theory is you try to solve the relaxed problem. Try to solve, say, forget about this inequality, right? Try to solve first and the fourth. If it solves the model and turn out it satisfies that, then you're done, right? That is what we call guess and verify because you are not able to try everything, right? So the easiest is, why don't I just solve the problem that forget about some constraint, solve it out, and it solved, it turned out it's right, then we're done, right? That is usually the technique that we use is, of course, some economics can help, right? That's why we can see, right? Because you will see the low type, right, is better, right? So the low type cannot mimic the low cost can mimic the high cost, but not other way around. So that means that the U lower bar must be strictly bigger than the U upper bar, right? So that is how we can guess the solution. Okay. So once you say this is the solution, you put it back, right? Then it becomes a unconstrained problem, which we know how to solve, right? Because there's no more constraint, right? The only two constraints, you put it back to the problem, it becomes an unconstrained problem. There's no U upper bar and no lower bar, right? And put it back, only Q lower bar and Q upper bar. And this is a concave function there, right? So you can easily find optimal there, right? By differentiation, right? You can easily check, you differentiate lower Q, only this exists, this here, right? That means that the low cost, the payment to the low cost guy, same as the marginal cost. That means that the second best quantity is same as the efficient one, which is the star one, right? The complete information one, they call star, right? So this is the efficient one, right? Because efficient, if you know the type, this is what you do, right? If you know the gas low type, this is what you do. But for the high type, right? And that we have to be different, okay? So for the low cost production, you can see the production, okay? Payment, okay? It's not efficient, right? Supposed to be here, but you add something there, right? And how much you add is this delta theta. Why? Why is the case? Right? It is because later we will define, this is called information range. Okay, let's see. So we see that, right? This is the S, right? So we can calculate the payment as well. The payment to the low type turn out to be like this. Okay. And the payment to the high type, okay, will be this guy, okay. And that means, okay, as we see already, the high cost type gets 0, okay. The low cost type get positive rand, and the rand is proportional to delta theta, right? And that part means because the principal doesn't know the agent type. The further they are away, the high type is going to gain, right? Because in order to make high type produce efficient, you have to give him some rent, right? Because he has some information advantage. Okay? And you have to distort the low type. Okay. And here you can see the low type is producing the marginal is more than that, means that the low type is producing less than they should in efficient. Right. So the idea is, later we see the graph, is the high type, the low cost type will actually do efficiently, but the inefficient one actually producing less, right? They earn less, right? In that case, they don't want to, don't allow the high type to, the good type to mimic the bad type. Okay? The efficient one don't want to mimic the low type one. Okay? And I don't have the graph. Oh. Sorry, I should have the graph here, but maybe this old slide. You can check the book. They will give you very nice graph, but I should have a graph here. Okay. But just to remind you, what is the main conclusion here? The main conclusion here is in the Morgenhauser model, so adverse selection model, the efficient one would do as they should have done in the complete formation setup. Okay, but you have to make, in order to prevent the efficient type to pretend to be the inefficient one, you make the contract for the inefficient type inefficient. Okay, that's why this is more than that, right? So in order to make sure that, okay, you would not be worthwhile to pretend. Okay? So that is the main idea. So that is actually can apply to at least 4 different contexts, the Morgenhauser. There are more. The first is tell us how to regulate monopoly. The second is how to do price discrimination, right? Because the firm doesn't know consumer how much they want to spend, right? So they want to design a contract, okay, by separating rich or poor consumer, right? And there also a bank loan idea, right? Try to have different interest rates, and also the labor contract. Later we'll go into one by one. Okay. The first one is Barrow and Meyerson paper, okay, which said there's a regulator, right? In Hong Kong will be, say, natural monopoly, right? Like the power company or power company, right? You say they regulate the firm, right? But the government doesn't know high cost or low cost to them, right? Because they usually this firm get compensated for the production, right? The state-owned enterprise. So the objective of the principle, right, is to maximize the consumer surplus S minus the T. T is the fee payment T, right? And the monopoly profit will be the payment minus the production cost, right? Theta Q. So this objective, right, is the surplus minus the cost production, and take away some of the part of the monopoly profit, right? The outflow of that, right? Because you don't want to have profit. Okay. So actually, this turned out to be, even though this new thing you can solve the same problem, it's still the case that the second breath is also allowing the efficient firm to produce what they want. Okay. The inefficient firm is producing something similar, what we see, except this guy. Okay, a new term there. But the same idea, right? That how you regulate is very similar. And here is the application when you talk about nonlinear pricing, right? So that's when you have quantity discount, right? Sometimes when you go to, say, Sam's Club, that's what we know, right? Sam's Club is compared to the Walmart, right? Walmart is selling the price higher than the Sam's Club, but Sam's Club you have to buy a lot, right? Or Costco, the same idea, right? Why? That is to differentiate the two types, right? Or quality, right? You have Tmall, Tmall, and Taobao, right? Taobao, Tmall is selling much higher than the Taobao, right? But say, so that is the quality there. So you can see the same idea, right? The payoff is also the price minus the marginal cost, C times Q, right? And the agent payoff is theta times UQ minus T. The only thing that the firm doesn't know is the theta, right? The theta can be high or low, right? If you value the good a lot, the theta is high. You don't value if theta is low, right? So there is a rand there. And you have similar IC constraint, right? And also the PC constraint there. You can easily check these are all right. And the problem is again the same. Once you put that back in, become this guy. Okay? And as expected, right? Only the efficient type constraints binding. Right? The inefficient one look like this. We're very similar to what we have seen, right? So you can solve this, and there's always a distortion for the low type, right? The low type you distort it to make sure the high type doesn't want to mimic. Okay. So that is the main idea, the proof behind. Okay. And you can see this is somewhat slightly different from the signaling game, right? Signaling game is distortion on the high type, not the low type. Right? If you remember the separating equilibrium, right? But this is the opposite case because it is different story there, right? Because the contract is offered by the firm, not by the worker. So you can also have the similar idea. You change from quantity to quality, right? Now principle is no longer C times Q, but Q is a function of C and Q is a quality here. Okay, but of course, we made the agents linear in Q. The only thing we don't know is the theta. All right, the firm doesn't know what's the taste of the customer, right? Whether they like good quality that much or not so. Okay, so that would be the goal, right? Again, you can easily check. You can put them there. You can have the IC and PC everything the same. Okay, you can easily write down everything there. Okay, and again, the same. It's also the IC upper constraint and lower PC binding. So the formula is very similar. So you can see, the same structure there, right? Always the IC upper binding and PC lower binding, right? And finally, I think this would be the last one we talk today. Okay. It's about financial contract. Those of you who are doing finance accounting would probably like this one, right? So I slow down a little bit because this one is different, slightly different from what we have, but the idea is same, right? The same as the one that we have for the quantity discrimination, right? So here is the difference is, where is the pen? Okay, it's here, right? So the principal payoff depends on how much money he get minus the market interest rate R. R is given by the market. So R is the parameter of the model, right? It's the Fed that decide the interest rate. And K is the firm, right? The principal decide T and K, right? Okay. And he decide what is the size of the loan, and then what he demand the guy to return is T, right? K is amount I lend to you, and T is the amount that I require you to pay me back, right? And that defines interest rate, right? The ratio. And R is given by that, okay? By the system. So now the agent is, say, the borrower, right? It depends on how he can convert the K money, right? The potential function F, right? So standard neoclassical potential function, right, is increasing in the K and increasing at decreasing rate, right? And his payoff is minus T, but there is a theta, right, that tells us how good he convert that based on the technology, right? Theta higher, they're able to get a lot more mileage for the same amount, right? So this is a model, okay? And you can see this is when you have the two type, that is the same as what we have seen, right? Just outsourcing problem, right? Decide how much you are going to ask the firm to produce, right? Outsider to produce, and how much payment you're going to make to them, but it's just reverse, right? Just same idea there. Then you have the same information range. You have same the IC curve, PC curve there, okay? And once you do that, right, it becomes this optimization problem, right? And the IC constraint, PC constraint is no longer relevant, right? Because once you have that, you will be seeing that only the IC upper bar and PC lower bar is binding, right? And that means that in the best case scenario, the high type will have efficient allocation of capital, right? And the capital is offered at the market interest rate, right? So those efficient will be doing the thing that they should have done in the complete formation, right? The good borrower would always would not have distortion. They're not affected by the system. Okay? The only troublesome is those disadvantaged, right? Those who are actually not so good, right? And they actually cannot borrow as many as they want, as much as they want. And that is referred in the finance literature called credit rationing, right? They are not allowed to borrow as much as they want, right? Because you are not very good. I don't know, because information asymmetry, right? That means that they cannot borrow at the market rate, right? And they have to, the interest rate is higher, right? You can easily check. The interest rate is higher than in general. Okay, so that is all the application, right? You can see this more adverse selection is very versatile, right? Although I just skimmed through it, but you can see the proof is very similar, one or the other. So I didn't go in the great detail. Okay, so up next week, okay, we will go over the Moore-Hauser mechanism design for the first 2 hours, and then the last hour we will do a exam, okay, in-class exam. Okay, so I will see you next week, because now to the end will be the CTE. So you will fill that in, and then I'll see you. So for you in the Zoom, probably you should also do the CTE, but I think our TA will tell you how to do this. See you guys. See you next week. Good luck for the exam.
Okay, class, now it's time for course and teaching evaluation. Please go to your CHK email account and locate the email which you should have received yesterday and click on the link to start the traffic. You'll be given about 15 minutes for this. So do you have CHK email account? Because the link was sent to you over email. So only if you have the email, you have the link. Okay. Okay, once you have finished, you can leave. This is the end of the class.